All right, we're going to get started on section 5.3. We do have some material in here that we've been talking about already, which is great, kind of putting together all the pieces with the unit circle here. So we're going to start by identifying the appropriate trig ratios within the unit circle. You'll notice my picture off to the right hand side there. It's called a unit circle because the radius is equal to 1. And I have a small diagram of a right triangle fitting within that. Remember that the cosine value is the x value in the unit circle, and the sine value is equal to the y value. If we were to set up trig ratios with those letters, the cosine would be adjacent over hypotenuse. That would be equal to x divided by r. The x length divided by the radius of the circle. Sine would be opposite over hypotenuse, opposite from that reference angle. So y divided by r. Remember that tangent can be equivalent to sine over cosine. That's really important. And if we were to set that up, that would be y divided by r divided by x divided by r. If you multiply by the reciprocal, you end up with y divided by x. The evil twins, that's a little nickname for our reciprocal trig functions. Remember that c goes with s and s goes with c, so that reciprocal function for cosine would be secant of theta, and that is the reciprocal of x divided by r, so that would be r divided by x. Cosecant of theta would be the reciprocal of our sine, and that means that that would be r divided by y, and then our reciprocal, or our evil twin for tangent, would be cotangent of theta. That would be cosine, notice co and co, divided by sine, or when we simplify that, x divided by y. So that, I just did everything from a reference triangle that was in the first quadrant, and that certainly is not always going to be the case. So let's start talking about these quadrants and where they're positive, or maybe where they're negative as well. So if you think about x values are going to be positive in this direction, and that means that cosine would continue to be positive both in quadrant 1 and in quadrant 4. Those are the two places where the x values or the cosine values are going to be positive. Sine values, this is asking where are my sine values less than 0? Less than 0 meaning negative. Sines are going to be negative where the y values are negative. That's going to be down there, and that means that would be in quadrant 3. And also in quadrant 4. Next, tangent. Where is tangent positive? Well, tangent is positive when you have a positive over a positive. That's going to be here. And then also if you have a negative divided by a negative, which is going to be there. So in quadrant 1 and in quadrant 3, tangent is positive. Lastly, cosecant. Cosecant is the reciprocal of sine. So if we're asking you where cosecants are positive, that's really asking where are the sines positive, and that would be in quadrants 1 and 2. I learned a memory trick last year. Actually, Mrs. Kortik taught this to me. I had never heard this before. And she says all students take calculus. And if you use those letters A, S, T, and C, what those are referencing are the quadrants in which trig functions are positive. All trig functions are positive in quadrant 1. Sine is positive only in quadrant 2. In quadrant 3, tangent is positive only. All the others are negative. And then C in the 4th quadrant would stand for cosine. So all students take calculus. Help us remember where sine and cosine are positive throughout the unit circle. Okay, so let's do that to do an example, finding all 6 trig functions for the ordered pair 4, -3. X value of, get my horrible circle. Let's try again. X value of +4. Y value -3. That's a 3, 4, 5 triangle. Remember, our radii are always going to be positive. Here's my theta, my reference angle. Remember, it's always created with a vertex at the origin, and you're always going to have an acute angle there. So sine of theta would be our opposite divided by our hypotenuse, or you can think of that as our y divided by our r, so negative 3/5. Cosine of theta would be our x divided by r, so that's going to be 4 divided by 5. Notice that's positive in the fourth quadrant. Cosine is positive. Lastly, tangent is sine divided by cosine, or we can do y divided by y divided by x. That would be negative 3/4. Doing the evil twins or the reciprocals. C goes with S, S goes with C, so the reciprocal of sine is cosecant, and all you need to do is flip that fraction. That's negative 5/3. Secant of theta, positive 5/4, and cotangent of theta, the reciprocal of negative 3/4, would be negative 4/3. Next, some vocab practice here. You've been hearing me use that phrase reference angle, but I probably have not yet defined it. It is an acute angle that we use to get back to the x-axis. So for instance, in example 1, 210 degrees, if you think about where that's located on the unit circle, I'm doing a sketch here, but I typically would just be doing this in my head. If I were to measure in the positive direction from 0, this would get me to 180 degrees. And to get to 210, I'd have to go 30 more degrees. This is the reference angle, and therefore positive 30 degrees is the reference angle we're looking for there. Example 2, 50 degrees. Measured from positive to 50 degrees. Guess what? That's my reference angle. 150 degrees. From positive all the way over here, I'm interested in what is the acute angle that is made with the x-axis. So we have 30 more degrees remaining to get to 180. So there's my reference angle there. I'm going to get a new picture so this doesn't get too out of control. Example 4, negative 225 degrees. So think about where that's measured from. We have to measure clockwise when we're going negative. This would be negative 180. Which means I have 45 more degrees to go to get to negative 225. But again, I'm interested only in the reference angle that is there, which would be 45 degrees. Now in some radians, 3 pi over 5. So 5/5 pi would be here. So 3/5 pi would be before that. And how many pi short is it? That would be 2/5. It's 2/5 short of 5/5. That's the acute angle. And lastly, 7, that must be radians. 7 radians. Think about that. From 0, measured in the positive direction, all the way around is 2 pi. 2 pi radians is about 6.28 radians. So that means I have to keep going. If I subtract 6.28 radians, I get about 0.72, 72 radians. All right. I think I'm going to stop there, and we'll pick up the rest in a part 2 video.